Hello, everyone. So we are going to start the episode 8. So this episode, we are going to learn what is the conditional statement and how to use the if statement. Before we start, the last time we learned about the loop. So as we discussed before, computer is very good at the repeated job. However, the the computer programmer really hate the repeated the statement like if you move several times, so it's really tired to the type everything. Instead, the programmer would like to simplify such the repeated statement. How? So we learned about the loop. The using loop, we can very simplify the code, and eventually it's very easy to understand such a code, and also the very easy to make the code. So there are two types of loop. One is the for loop, and another one is while loop. So for loop is when you know the target. So when you know the target, so you can use such a the target as the list or array, then we can for each element of the array, so we can do the repeated job. On the other hand, while is if you do not know what is the target or the repeated target, then at the time you can continue until satisfy the condition. So if the test condition is not true, then we can out of the loop like that. That's what we learned. However, so while we are using while loop, so we can test, evaluate the function. So whether this is true or false. But however, such a test or the evaluation, the statement can be used another. If this one is true, we can go for this. If not true, we can go another way like that. So today we are going to see such a conditional statement. Actually, the computer program has bunch of the conditional statement. I believe the if statement, conditional statement is the most important statement that used in computer programming. So we will see what is such a conditional statement in the carol and how we can control the carol like that. Okay, so before we start, I'd like to continue the story that I introduced last time, the episode 7. So that is we talk about the binary number and decimal number. So people are familiar with, human beings are familiar with such a decimal number. However, the computer can use only binary number. So let's change my desktop into the my iPad like this. Okay, so here. So last time we saw why computer likes the binary, because the electricity is it easy to make the 0 or 1 like this. So we can control the current using the what? What is this? Using the resistance, so we can control such a current level. So we can say that this one is low current is 0, high current is 1, like that. Eventually, we can have the binary number. So computer, if we can represent such the binary number, like think about the bulb. So if we write on the bulb, so if the light, then this one is 1. If off, this is 0. Then if we add the switch over here, that will be transistor. If we have the bunch of transistor, this one will be integrated circuit IC. Then VLSI, then eventually it will be our semiconductor memory and so on. So this is a computer. Then we will see how computer is using such a binary number. So before that, we'd better understand what is a binary number system. So for example, if we have the 1011, so if this is the decimal number system, what's the real value of this number? It's 1011. So which means, so if we evaluate the real value of this number in terms of the decimal, so this one is actually 1. What about this? This is actually each digit has the value. So the one has the 10, right? So this one is the 100, and this one is the 1000. So even though it's the same number, but their value are different based on what? The digit, okay? Then we can multiply. So however, if this is the binary number, that's a different story. In case of the decimal number, it's 1011. However, if this one is the binary number, so there's a 0 over here. So it's a 0. So if this is the binary number, its value is, how can we calculate? Why don't you remind the elementary or the middle school math? This is 2 to the power of 0 and 2 to the power of 1. So exponent will be increased by the digit. So 2 to the power of 2, so 2 to the power of 3. That means this one, the value of this digit is the 1, and this is the 2, and this is the 4, and this is the 8, like this. Then multiply by this, and this. So it's eventually this one is 2, and this is this is actually the 1, right? Because its value is 1, so the value is 1, and this is a 2, and this is a 0 because it's the value of this digit is the 0. It's a 0. Then this one is 8. So what we're gonna do is add up all of this. Then that will be 11. So 11 is in terms of decimal, this is a real number. So we can actually convert between the binary number and decimal number. Then that is a clue because the human being, we are familiar with such a decimal number system, but computer likes such a binary number system. So whenever we use computer, we can convert, we can change such a decimal number into the binary number. Then computer can understand what we are asking. Okay, so we will see such a conversion in a short time, but before that, so each one is called in computer, as we have seen. So each digit is called the bit. So 1 bit means one such a device. So can represent 1 0 or 1. So this is another bit, and this is another bit, and this is another bit. So to represent 1 0 1 1, how many bits do you need? You need 4 bits. If you have the 1 1 0 0 1 1 0 0, how many bits? 8 bits. So nowadays the rap or the rhythm line, such a music are very popular. It has a beat, high beat and low beat, and the 16-bit, 100-bit. So that is a bit. A bit is the very, very basic unit of such a computer number. So among them, so bit is not easy to represent a specific meaning. So we are going to combine the 2-bit. If we have the 2-bit, in other words, if we have the 2 verb, so we can represent this 0 0 0 1 1 0 1 1, 4 different number. So such a 2-bit is called the nibble. So 2-bit is the same as the 1 nibble. Okay, so 1 nibble means 2 bit. So also, if you have the 4 bit, like this one has a 4 bit. So how many different number can you represent? Total 16 different numbers, 0 to 15 in terms of the decimal number. This one is called 4 bit, is called 4 bit. 4 bit is actually the nibble, sorry. So it's a nibble. So then we have the 8 bit. If we have the 8 bit, 8 bit is called, it's a byte. So if you are talking about what is the memory size, so it's a 1 gigabyte. At the time, 1 gigabyte means you have how many byte? The gigabyte. Giga times of byte. If you are saying the 1 megabyte means how many byte? 1 million of byte. If you are saying that my computer is 1 terabyte, meaning is I have the 1 tera times of byte. Such an information can be stored. So at the time we can use the byte. So byte actually has 8 bit. So because of this one, so if you are using the internet, so internet provider, sometimes they say the internet service is the 32 megabps. So what that means? So what does the 32 megabps mean? It's the 32 millions of bit per second. It's not actually byte, it's a bit. So actually, we are familiar with the byte. So we will see why, but in terms of byte, it's divided by 8. So actually, it's a 4 megabyte per second. So internet provider, they actually exaggerate the speed. So even though you are seeing the 32 megabps, that doesn't mean it's a 32 megabyte per second. So if you check your internet speed, using the tool or app, it's like the 4 megabyte or less. So you shouldn't realize the real speed. So because of such a unit. So computer meaningful information is stored at byte. Why? Because it's the conversion. When we convert such a binary number into the decimal into the byte, 8 bit is the minimum. Then this one is a 1 byte. So 1 byte means 1 character. So if I write down the LEE, so L is 1 byte, and E is 1 byte, and E is another byte. So total how many bytes? It's a 3 byte, like that. Okay, then let's see how computer uses such a bit or byte. So for example, the hard disk drive is like this, because the hard disk drive inside there is a disk, and disk has like the number of many track. Inside the track you are going to like this one. There are number of 0 or 1. So if there is a hole, it's a magnetic hole, and this one is 0. If closed, this one is 1. So if you have the 1, 2, 3, 4, 5, 6, 7, 8, then this 8 hole or closed solid, represent this one is 1 byte. Then if you have more and more, so that will be 1 megabyte, 1 gigabyte, and 1 terabyte of data will be stored. And also, as we learned before, computer has the memory here. Memory also, if we zoom in such a memory structure, memory is just like this. It's array of the data. This data is starts 0, 1, 2, 3, 4, 5, 6, 7, 8 byte, 8 bit. 8-bit information like the 11001100 like that. Then this one represent 8, for example, like that this. So then, so another 11110000, this is the B, like that this. Then we can store the data on the memory. And even CPU use the same idea. The CPU, we have the CPU. So memory, data in the memory will be transferred to the CPU, and CPU has such a information. Sometimes such a number 11110001 meaning is it's an add, like that. Then add 00000001 is a 1. Add 1 plus 00000011 is the 3. So 1 plus 3 will be stored at the eventually memory, like that is. So computer use such a bunch of the bit, eventually byte information. So that is the very basic unit of the data used in your computer system. Then this is a bit and this is a byte. Then what about your program? Your program does not use such a binary number. Then how does computer understand that? At that time, as I mentioned just before, so computer use what? Binary number. But human being, user use decimal number. So we are going to convert the decimal number to the binary number to the decimal number, right? So that is the conversion. Then how can we convert? So people thought about this. Is there any way to convert conveniently, so such as the binary and the decimal like that? So it's called a code. So code, let me copy and then go back to here. So let me change our desktop like this, and I'm going to, oops. So this is the conversion table, which is called the ASCII code. So ASCII code is it's an American standard, the code for information interchange. It's an information interchange. Meaning is we are going to change the information, character or number into the binary, and binary number to the such information. So if you take a look at the value like this, let's see the, oops, yes. So for example, so A is what? It's a 101000001. This is the A. And what about the B? 01000010. So for example, if I convert the LE, so let me erase this, then the right here, E. So this is the alphabet, but if we convert this one into binary, so let's check where is the L. L is here. So L is 01001100. So 01001100. This is the binary of L. What about E? E is 01000101. So 01000101. So another E is the same thing. So this binary number, when you type or when you see the data, computer actually convert this into this binary code and this binary code and this binary code. Then this binary code will be saved in your hard disk drive or memory, even CPU. Then computer can understand your code. So, but as you can see, so if you see this, it's a 4C. 4C. If we are using the decimal, how many bits do we need? So 10, so 2 to the power of, for example, in this case, so it's up to the 2 to the power of 8, right? Because it has the 8 bit. So we can actually represent more number. So decimal, it doesn't fit too very well to binary. Instead, we are going to extend the decimal into hexadecimal. Hexadecimal means it's a 16-digit number, 16-bit number, the 16. So hexa means it's a 16. Hexadecimal. So hexadecimal is we are going to use the 16 different number for each digit. For example, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, no 0, A, B, C, D, E, F. So these are the number, so we can represent the 16. So each one, so 2 to the power of 4 is a 16. 2 to the power of 4 is a 16. So that is the reason it's a 4C. So program language, instead of decimal, actually we are using such a hexadecimal. Then easy to convert what? Binary using ASCII code table. The ASCII code table using this one, we can convert. Then the computer store such a data bit by bit. Okay, so once again, we are using the decimal number, but computer use the binary number. So eventually, so we are going to convert such a number from decimal to hexadecimal, hexadecimal to binary, and computer store such a binary code. Okay, so that is the reason. So we are using 8-bit as a very basic unit. You can see over here. So we can represent most of them. Nowadays, we have actually more of that. So like the what? So we have, actually we have what? The emoji even. And some, like the Asian character, like the Korean, Chinese, they need a little bit more. So Unicode is nowadays we extend the ASCII code to the Unicode, then Unicode to the Unicode 8 and 16. Then nowadays we can use the emoji as a standard like this. Okay, so that is the binary and the decimal number. Then eventually we are able to understand. Okay, then, so let's try to solve today's problem, which is called the invert beeper. So here the question. So we have the 8x8 the carol sword. So 8x8 the carol sword like this. The carol is located the top left corner. Then would like to move the other end. This is very similar as the last problem. So last problem, so using while loop, we implement move to work. How? Using while loop. Do you remember that? We use the while and then move until when? So front is clear. Yes, right. Front is clear. The test function we use. Then it move until it's the front is blocked. That's what we have learned the last time. Okay, very nice then. But today's problem is slightly different. Okay, let me a little bit change it. Okay, so this one is better. Then here, so while the carol is moving, if there is any beeper, the carol pick up. Okay, so that is the reason that after the carol move, there is no beeper over here. However, if there is no beeper, the carol would like to put beeper. Okay, would like to put beeper. Very simple. Then after you run your program, so it should be like that. So it's an invert of a beeper. If there is no beeper, put beeper. If there is a beeper, pick beeper. So like that. So third one, no beeper, so we can put beeper. And there are beeper, so we can pick beeper. And there's another one, so we can pick beeper. And this one, the last one, so there's no beeper, we can pick beeper. So this is called the invert beeper. So how can we do that? So we need something to decide based on what? Condition. What is a condition? We need to check whether there exists a beeper or not. To do that, computer programming, Python provide the if statement. So if, it's very simple. So if, then we can put the test function over here. Then we are going to put the colon like that. So colon means what? Colon means there will be code block. So if this is true, then run this code block. So very simple. So we will see the so this is the basic code. If test, the test function, do you remember that we learned the test function last time? So this is a test function. The last time we used the front is clear. Then what function we can use? So why don't you read the test function provide the carol? Then what we can use? Yes, so we can use the beeper present. So if there is a beeper, what? Pick beeper. Then if not present, we can put beeper like that. Very nice. So we can start the program. So as a user, please start the Python. Then start the anyone Python the project. So today's Python file is so E08. So it's 8. So invert beeper.py file. Okay, so let's just start. So first, why don't we start with the if? So if, so we are going to use the beeper's present. So beeper's present. Then don't forget, always colon over here. Colon means there will be code block. So if beeper's underscore present is true. If this one is true, then we run what? The put beeper. Oh no, the pick beeper. If there is beeper, we are going to pick beeper. Let's test this program. So to test the program, we are going to run yes, it's an 8 invert beeper. Run the program. So what happened? Because carol is here. So beeper's present. Is there any beeper in the spot? No. So that means pick beeper is not the running. Instead, just exit. Then how can make the carol? So let's test with the no beeper present. So we can test this one, no beeper present. Then we are going to this time put beeper. put beeper. So let's run it again. So there's a the carol. If we run the program, yes, you can see the, let's say listed those who missed. After I run, there is a beeper present because no beeper present, so I put beeper. So this is an if statement. So let's get back to the original problem. So what we want to do is the first, if there is the beeper, we pick up. If not, we are going to put beeper. So do I need to use the to if statement? That's not a good idea. So there is another, the way to use the if statement is if this is true, we are going to run the this. Otherwise, if not true, false, else. Yes, we are going to use else. Else and with the colon. Why? Because it has the code block. So code block is a, so why not do this way? If there is a beeper, then if beeper present, we pick beeper. So pick beeper, then if not, S is a put beeper. Yes, very nice. So we are going to test it. So if there is beepers present, if there is a beeper, and pick beeper. Otherwise, S means if this is not true, then put beeper. Okay, so let's run the program. Here is the carrot's word. If you run the program, yes, the carrot put the beeper. Okay, so why don't you run your program like this, then test it. If you want to test your program, the more you can load another map. So right now we have the one by one. So you can test with one by one. There's no beeper. So if I run this program, it's probably my program put beeper. So run the, yes. If you run this program, so carrot put beeper. So let's test with another one, like the 3 by 6. There's no beeper. If I run the program, put beeper. And then also another one, 4 by 4. So if you run the program, yes, it's a put beeper. And the 7 by 7, run the program, yes, put beeper. So it's run correctly. So why don't you the code this? If there is the beepers underscore present, then the pick beeper. If this one is true, otherwise the put beeper, like this. Okay, so very nice so far. So then let's see the more example of the such a if-theners. So first we have learned about the if. So if statement, and we can put the test function. So Carol provides several test function. So as we have seen here, so you can use such a test function. Okay, you don't have to memorize. If you need, you can check the reference site that I gave you before. Okay, then, so you can If the test function is true, then we are going to run the code block for the if code block. This one is called if code block. So don't forget, this is very important. Always colon. And colon expect the what? Code block. Code block should be the same indentation. How many space? 4 space or 1 tab. Very nice. Then mostly we are using if statement with else. Else means if this test is not true, then we are going to run else code block like this. Okay, if this one is true, if code block. Otherwise, then else code block. And also, it is possible. Why not? Multiple tests. If test A is true, run this. Else if B test is true, then run this. If you have another test C, and run this. And if another test is true, run this. Otherwise, if not all of them are true, run this, like this. So this is called the multiple if, the if statement. How many? You can put as many as possible. However, if and else is only one time. Okay, so this is a multiple if. Here is a question. If A is true, which means your Python run this if code block, then what happened? Does it check the next one or end of statement? Yes, it's going to end of statement. So for example, if C is true, run this, then end of statement, next command. And if D is true, run this, then end of statement like this. Okay, so this is called the multiple if statement. Okay, then let's go back. We are going to finalize our invert the before problem. So our problem is we are going to make the caret move here to the end, right? We can make it. How? How can we make the caret move? Do you remember? Yes, we can use either for loop or while loop. Which one is better here? So while loop is better or for loop is better? For your hint, for loop is good for when you know the target. While loop is good for when you do not know the target, but you know the condition. So in this case, caret is moving from to the end of word. Do you know how many the size of a word? So we don't know. We can change. We can change it, the size of the word. So instead, we are going to make the caret move until what? It's clear. If not clear, stop. So which means, which one is better? While loop is better. So we are going to change the code while loop. So while, do you remember the last time? Move until when? Until front is clear. Very nice. So until front is clear. And don't forget the semicolon at the colon. So that expect what? The block. While block code. Code block. So that's it. So then let's test this. We can make the command like this. Then run the program. Then run the program. Move, 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 move. Yes. So this is a move to work. Then while the caret is moving, what we're gonna do is we are going to run this if statement, right? So here, here. Instead of put this one inside, why not create the function? Yes, that is better idea because we may use the function later. So we are going to create the function like the invert the beeper and the colon. Meaning is that the function block will be executed whenever it's called. So we are going to call this function invert underscore beeper. Then the movie, right? Do you think it works? So why not try? Okay, I will give the couple of more minutes to finish the code. Then you can run the program. Okay, very nice. Why don't you try? Also, when you can keep coding to solve the problem, but whenever you create the function, it is good idea. It's kind of a habit to put the command at least one line of command, like for example, it's the invert beeper function to invert the beeper, like that. Why don't you put the command for each the function? If you have any specific information like the input, you can specify the input or any other information like that, but at least one line of code. Okay. Also, it is also a good idea if you add more information for each line, you can put the command after your command, like put pick up beeper, or you can beeper when the present, like that. Then it's clear what you wanna do in this the program. Okay. Did you run the program? What happened? So let's run the program. Okay, then run the program. Carol is moving and pick beeper or put beeper. Yes, it's very nicely done. Looks like very nice. So you can see the Carol put beeper over here because it's nothing. Very nice. And second, it's a pick beeper because there is, and the put beeper because there is nothing over here, and the pick beeper 4 and 5 because there are beeper. And 6 there is no beeper, and you can pick the put beeper. 7 there is a beeper, so you can pick up. Then what about the 8? 8 supposed to be here. There is no beeper, so you should put beeper like this, but in the result there is no beeper. So something wrong. It's not complete yet. So what is the problem? Can you check what is the problem? Anyone? So this is called what? This is called fence post problem that we discussed the last time. So fence post problem is when you are using the while loop. So you should repeat one more time. You should run the command or code block one more time to make your program while loop program perfect. So it's like when you build a fence, you should have one more post than your fence. Why? Because you have the post like here, poster. How many fence? 2 fence. How many posts? 3 posts, like that. But your loop only cover this part and 2 times here. So you should add one more post. You should run one more program. What about here? In your code, what will be the post? Post is invert underscore beeper, right? Because you first check the here, then the move, check, move, then check, move. There's no check because at this time after move, you are going to check the front is clear. Yes, front is clear. So you should out of while loop, then it will be end. So because of that, last invert underscore beeper is not executed. One more time. So if you run this code, let me run the code again. But it's so far so good and very nice, very good. But last one, we expect the put beeper over here because there is no beeper, but it's not the put. Why? This is called the fence post problem. Fence post problem is like when you build a fence, you need one more post like this, one more post. So fence is 2, but you need 3, the post, which means when you run the while loop, so first check the invert beeper. So there is no beeper. So no beeper is a put beeper. Then the move. So move to the next. Then if there's no beeper, there is a beeper. So pick beeper. And so on. Then last part, the invert underscore beeper check. There is the beeper. So you can do what? Pick beeper. Then the move. So move goes to the last part. Then check front is clear. No, it's not clear. It's a false. False means you are not going to run this. Instead, and the while loop. So because of that, the invert beeper is not running. So how can you solve the fence post problem? To solve the fence post problem, we can put another post. So we can put another comment out of right after the while loop. So here, okay? So as I suggest, it's kind of the pattern of while loop. Always you need to check whether this is the fence post problem. So if yes, you are going to run the command one more time. So why don't you try to change your code? Change your code and run it. Okay, so how it works? We are going to put the post over here. Front is clear. Okay. Then run it. Let's see how it works. So it looks like the good so far. Then what happened? The last one. It doesn't look like good yet, right? So actually, it's invert beeper, right? So invert beeper, and run the program. then the calories moving, and the last one, you can see, as you can see, the beeper is present here because you put the beeper. Okay, so this is the end of code. Okay, so today we have seen how to use the if statement. Also, we have seen, we have learned how we can use how we can convert the binary and the decimal. So next class, we will see more details of how can we improve our coding skill using the refinement. Thanks so much for your watching, and please practice with the sample code. Thank you so much.